Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video, subscribe to the channel. Now let's see today's problem of the day. Count sorted digit groupings. Given a string as containing digits, you can split it into contiguous substrings, subgroups. For example, the string 112 can be split into the first element will be 1, then 1, then 2. Or this 1 grouped together and 2 is left only, then 1 single one, then 1 and 2, then all the three 1 1 2 are combined. So grouping is considered to be valid if the sum of the digits in the subgroups form the non-decreasing sequence from left to right. Determine the total number of such valid groupings for other given string. So in this question we are giving a string which contains some digits, and we need to count the number of valid sequences that we can get by dividing this array into the groups, and every subgroup has the non-decreasing like sum from the left to right. So let's look at this example. We have 1 1 triple 1 9. So we can divide this string into uh, uh, seven what we can 7 ways, such that every group has non-decreasing sum from left to right. Let's look at the one valid subgrouping is 1 1 1 1 and 9. So the sum of the first group will be 1. The sum of digits of second subgroup will be 2. So 1 is less than 2. It is so it is valid. And the last we have 9. So we have 1 less than 2 less than 9. So it is a valid grouping. So we get 1. Similarly, the other valid subgroupings are something like that. Well, 1 1 1 9. So 1 1 will be 2 and 1 9 will be 10. So 2 is less than 10, so it is a valid subgrouping. So total we have 7 valid groupings. So how we can solve this problem? We can use an recursion here. We can try to partition at every index, and we can check if this is a valid subgrouping or not. So let's look at a code here. We will call this solve function with the current index that we are standing at, the number of the length of the string s, then the string and the previous sum. Currently we have previous sum equals to 0. If we have reached the end of the string, we will return 1 because it is a valid groupings, and the current sum will be 0, and rest will be the total number of ways that we can find to divide this string into a valid groupings. So currently starting at the index, we will iterate over the string, and the current sum will be the s of I minus 0. So for the first iteration, I will be 0, and the s of I will be 1. So 1 minus this 0 will be 1. So current sum will be 1, greater than which is greater than or equal to previous sum, which is 0. So we will call recursively for the next, we will make the cut here. We will try to assume that we have make the cut here, and we will call recursively for this part 119, and we will store the number of ways into this res, and in the end we will return this res. For time complexity will be exponential because we are using recursion here. So to optimize the solution, we will use dynamic programming here. So what states we have? We have this index which is changing, and we have previous sum. So the index will be of range 0 to n. So n will be the maximum size, and for the previous sum, we have the size of this array, this string will be 100, and the s of I will be in the range from 0 to 9. So the maximum previous sum can be 9 into 100 will be 900, but I am taking 901 because it is zero based indexing. So we have made this 2D array, and we will check if we have found we have filled it with -1. Then we will, in the solution we will check, in the solve function we will check if we have previously visited that state or not with index and previous sum. If we have visited, we will simply return, else we will call this recursive function, and in the end we will store the result into this db. So guys, if you find this video helpful, please like this video, subscribe to this channel. Thank you.